Thank you for your interest in SuperPro Designer. This two-video series will provide you with a clear picture of the features, capabilities, and benefits of SuperPro. In part 1 of this video series, I will introduce you to SuperPro Designer by giving you a brief overview of the purpose and typical applications of SuperPro, an orientation to the graphical user interface, and a summary of many of the main results from SuperPro. In part 2 of this video series, I will finish summarizing the results from SuperPro. Then I will provide you with descriptions of various industry-specific examples. And finally, I will provide conclusions and guidance. SuperPro Designer is a versatile process simulation, cost analysis, and optimization tool. It handles continuous and batch processes, as well as combinations of batch and continuous. SuperPro is used by scientists and engineers to perform modeling, analysis, and optimization of integrated processes. IntelliGen also markets a companion tool called SchedulePro, which handles modeling, debottlenecking, and ongoing production planning and scheduling of multi-product facilities that operate in batch or semi-continuous mode. This video will focus on the features and capabilities of SuperPro Designer. If you are interested in production planning and scheduling, please make sure to also watch the SchedulePro videos. Process simulation and scheduling tools play a variety of roles throughout the life cycle of product development and commercialization. At the early stages of idea generation, such tools are primarily used for screening and evaluating new project ideas. In process development, they are used to evaluate alternatives from a process economics, cycle time reduction, and environmental point of view. They are also used to improve team collaboration by introducing a common language of communication among the various team members. As we move from development to manufacturing, such tools are used to size equipment and utilities and estimate the overall capital investment. They are also used to fit new processes into existing facilities and address issues of process flexibility and operability in multi-product facilities. Finally, in large-scale manufacturing, they are primarily used for ongoing process optimization, debottlenecking, production planning, and scheduling. In support of the roles described on the previous slide, SuperPro provides comprehensive process modeling functionality, including generation of full material and energy balances for integrated processes, calculation of amounts and compositions for all waste streams, including VOC emissions, demand profiles for resources such as labor, raw materials, utilities, etc., Gantt charts and equipment occupancy charts for batch processes, equipment sizing, and thorough cost analysis, including estimation of equipment cost, capital investment, and operating costs, with detailed breakdowns for the cost of materials, labor, consumables, utilities, waste treatment, and other operating costs. SuperPro's reports, charts, and scaling features also provide users with the necessary tools to perform cycle time analysis and debottlenecking, as well as process scaling to fit specific equipment trains. Finally, the outputs from the model, as well as the model itself, provide a platform for technology transfer from development to manufacturing groups or to different sites. Let's take a look at SuperPro Designer now. SuperPro Designer features an intuitive graphical interface that decreases the learning curve. Process models are constructed by developing a flow diagram like the one shown here. It is important to understand that the flowsheet itself is not an equipment diagram. Instead, the icons on the flowsheet represent unit procedures. Each unit procedure is a set of one or more operations that take place sequentially within a given piece of equipment, and multiple unit procedures can be associated with the same equipment item. I will discuss unit procedures in greater detail later. This particular model is one of about 20 examples that are shipped with the SuperPro Designer installation. This example represents a production process for beta-galactosidase, which is an enzyme produced by E. coli. Beta-galactosidase is used to convert lactose into glucose and galactose. This flowsheet is split into 3 sections: a fermentation section, in black, a primary recovery section, in blue, and a purification section in green. For large processes such as this one, it can sometimes be helpful to use the Overview Navigator window by clicking here. This window lets you see the entire process at once. In addition, you can move the rectangular selection window in order to find another section of the process and focus on it within the main window. Note that there are many customizations that can be made to the flowsheet, including changing the names, styles, and colors of streamlines, changing the colors and names of unit procedure icons, moving unit procedure icons and streamlines to different locations, pasting graphics or tables from other applications onto the flowsheet, adding notes to the flowsheet, etc. In order to build a flowsheet, unit procedures are first selected from the Unit Procedure menu. As you can see, there are a variety of unit procedure models available, including procedures for batch and continuous reactions, filtrations, centrifugations, drying, etc. Once a unit procedure has been added to the flowsheet, operations must be added to it. As you can see here, this blending tank unit procedure has 4 operations associated with it. If I select the charge water operation, you can see that a charge amount of 64,000 kilograms and a charge rate of 120,000 kilograms per hour have been specified. Note that additional information could also be specified, including information related to working volume capacity, emissions, labor requirements, scheduling, etc. The level of detail that is provided for each operation is completely up to the user. Therefore, if you are not interested in emission calculations or labor usage, you can skip those tabs and focus on the tabs that matter to you. This allows you to create basic models in SuperPro very quickly and easily, but it also provides you with more advanced capabilities if needed. Note that you can also rely on the default values provided by SuperPro to get reasonable estimates for operational labor, utility specifications, etc. In addition to defining unit procedures and operations, the flowsheet connectivity must be established in order to define material flows. This is done by clicking the Connect Mode tool and then attaching input, intermediate, and output streams to the unit procedures. The default stream names can be modified to make them easier to understand. Furthermore, the input stream compositions must be specified based on the materials available within the project. These materials are defined within the material database, which you can see here. SuperPro automatically registers 3 common components in every project: nitrogen, oxygen, and water. You can then register additional components specific to your project. For instance, you can select components from the designer database that ships with SuperPro, or you can select them from a user-defined database based on previous projects that you or your colleagues have built. Furthermore, you can purchase a separate license to the Dipper database for access to even more materials. You can also create your own proprietary components by clicking on this magic wand icon. This allows you to specify the names, physical properties, pollutant categories, cost data, and other relevant information for your components. Note that you can also edit the properties of the components that you import into your project from other databases. For instance, I could edit the properties associated with the glucose component by simply double-clicking it. Once you have finished adding and editing pure component information, you can exit this dialog. Note that if you frequently use specific mixtures of materials in your processes, you can create pre-specified stock mixtures from your pure components. This will make it easier to initialize input streams and track process inputs. After the materials and mixtures have been specified, they are available to be used within the operations and streams of the flowsheet. Other process resources can be specified through the Databanks menu. In addition to pure component and mixture databanks, SuperPro is equipped with databanks for heat transfer agents, labor types, consumables, currencies, facilities, equipment that you purchase from vendors, equipment cost models, etc. You can access and modify the databanks through this menu. For instance, here you can see the contents of the consumables databank. It is very easy to add your own specific consumables as well as your own consumable categories. The consumables of a process are specified at the equipment level through the Consumables tab of the Equipment Data dialog. I will show you the Equipment Data dialog in a minute or two. Another important databank is the Sites and Resources databank, which allows you to represent actual or hypothetical manufacturing sites, along with their equipment, utilities, and labor resources. If a process is allocated to a database site, it gains access to that site's resources and by default utilizes its cost estimation factors. This functionality greatly facilitates technology transfer projects and standardization of cost analysis. If you are interested in learning more about how SuperPro's database information is entered and used, please view the Databanks tutorial on our website. This can be found by navigating to www.intelligen.com, clicking on the Training menu, selecting the Videos option, and scrolling down to the Databanks tutorial. Once the project resources have been added, they can be viewed at any time using the Process Explorer. Here you can see the raw materials and mixtures available within the project, as well as their costs. You can also see the utilities for this project, the main equipment, etc. Furthermore, you can double-click these resources to view or modify their data. For instance, here you can see the data associated with chromatography column C101. Notice that SuperPro Designer has two modes for equipment size. Rating mode is used when you have chosen an equipment item of a specific size that is going to be used within the process. Design mode is used when you expect the program to size a specific equipment item in order to satisfy the requirements of a process. SuperPro will also automatically calculate the cost of that equipment item based on its size and other factors such as material of construction. Also notice that this particular equipment item actually has 3 identical units that operate in parallel. In addition to running multiple units in parallel, you can also operate equipment in stagger mode. This means that you would have multiple identical equipment items that perform the same procedures out of phase with one another. In other words, they would begin processing materials at different times. As you can see, there are additional tabs which would allow you to calculate or specify the purchase cost, as well as the adjustments to the purchase cost. In addition, as I mentioned a minute ago, you can specify all the consumables associated with the procedure through this Consumables tab. Here you can see the particular resin that has been selected for this procedure, as well as its cost, based on the value in our database. Note that right-clicking on a unit procedure icon will open this same dialog box. In general, right-clicking an object within SuperPro allows you to modify the data associated with the object. Keep in mind that this SuperPro Designer overview video is not designed to be a thorough training video. If you are interested in learning more about how to create models in SuperPro, please view the detailed SuperPro training videos on our website. As mentioned previously, these videos can be found by going to www.intelligen.com and clicking on the Training menu, then selecting the Videos option. The Batch Process tutorials and Continuous Process tutorials at the top of the Tutorials page are especially useful for learning the basics of how to use SuperPro for batch or continuous process modeling. After creating and initializing your flowsheet, you can simulate the process by clicking the calculator icon here. This will perform all the calculations associated with the process, including material and energy balances, resource calculations, cost calculations, and scheduling calculations. At this point, you can view any of the results associated with the model. For instance, you can double-click any stream to view its contents. Here you can see the amount of each component, the temperature of the stream, etc. Alternatively, you can add a stream summary table at the bottom of your flowsheet with the specific stream information that you would like. Just as you can view the contents of streams, it is possible to view the contents of the equipment during each unit procedure by simply right-clicking the unit procedure and choosing the Equipment Contents menu. This provides you with information about the equipment contents during each individual operation. In addition to checking the material balance information, it is a good idea to ensure the scheduling of any batch operations in your process is correct by visiting the Operations Gantt chart. This chart shows the durations as well as the start and end times for each operation within a recipe, both in table format and chart format. As you can see, the complete recipe is represented by this tan bar, the individual unit procedures are represented by dark blue bars, and the operations within each unit procedure are represented by light blue bars. Note that the process specifications, including the scheduling information for each operation, can be edited directly through this chart by simply double-clicking any operation that you want to modify. Furthermore, scheduling information, including task dependencies, can be readily exported from SuperPro to SchedulePro and Microsoft Project. The Gantt chart can also be copied and pasted into other applications such as Microsoft Word, Excel, PowerPoint, etc. Another useful chart for visualizing scheduling of batch processes is the equipment occupancy chart. This chart is particularly useful in identifying equipment cycle time bottlenecks. The y-axis of this chart lists the equipment items, while the x-axis corresponds to execution time. The bars represent the procedures that take place within each equipment item. In this example, there are 5 different colors of bars, which correspond to 5 consecutive batches of our process. Each of the batches begins with media preparation and fermentation, then moves through primary recovery, and finally reaches the purification procedures. The CIP skids, which are used in all sections of the process, are also shown at the top. Using this chart, you can readily identify the cycle time bottleneck equipment items because they have the least slack or idle time between consecutive batches. In this example, chromatography column C101 is the current bottleneck since it has the least idle time between batches, although various other equipment items are scheduled tightly as well. Note that it is possible to customize this chart and other charts in SuperPro by right-clicking and choosing the number of batches or modifying the style of the chart in order to include or exclude certain information. It is also possible to change the style of the calendar information that shows up at the bottom of the chart. In addition to scheduling of main equipment, it may be necessary for you to track various resources associated with your process. To facilitate this, SuperPro can create charts showing material inputs, inventory levels, product generation, waste generation, utility usage, labor requirements, and cleaning equipment over time for either single batches or multiple consecutive batches. For example, this particular chart displays the demand for operator labor as a function of time for 5 consecutive batches. As with other charts in SuperPro, I can change the number of batches by right-clicking in an open area and specifying a different number of batches. Now you can see the operator labor demand over 10 consecutive batches. As you can see, there is a brief peak demand of 17 operators based on the current production scenario. There is also a limit of 16 available operators that has been specified for this facility, as you can see from this red line. Therefore, in order to keep from exceeding the operator limit, either additional operators should be added to this facility, or certain operations will need to be delayed. Another type of resource chart is the raw material supply chart. For example, this particular chart tracks the consumption of water for injection, frequently abbreviated as WFI, as a function of time for 5 consecutive batches of our process. Notice that it gives the instantaneous demand, in red, which correspond to the units on the left axis, as well as the cumulative and time average demands in green and blue. In this example, the green cumulative demand bars show the total demand for WFI over each 12-hour period, and they correspond to the right axis. The blue time average demand bars show the average demand during each 12-hour period, and they correspond to the left axis. These time periods can be modified by the user. This chart can also be modified to remove the cumulative and time average demand lines if desired. For instance, with these changes you will be able to see only the instantaneous demand. In addition to resource demand charts, inventory charts can be generated for raw materials, products, and waste over the course of a campaign. Here you can see the inventory level, shown in green, within the WFI storage tank for 5 consecutive batches of our process. You can also see the supply of fresh WFI, shown in pink, flowing into the tank when the WFI still is active. In this example, the WFI storage tank has been set up to automatically refill at a rate of 20,000 kilograms per hour when the volume in the tank falls below a certain threshold. The demand profiles from the previous chart and inventory charts such as this one can be used together to determine the required capacities of your water purification, storage, and distribution systems. If you are interested in learning more about SuperPro's capabilities for WFI system design, please view the detailed WFI system sizing videos under the training page of our website. The ability to create resource charts for materials, utilities, and labor allows you to design adequately sized systems, effectively determine long-term material requirements and costs, schedule sufficient quantities of staff members during different time periods, etc. Another useful chart is the Throughput Utilization Indices chart. This chart shows the capacity utilization of each equipment item in dark blue, as well as the time utilization of each item in light blue. Combining these two factors results in the combined utilization in purple. These metrics can give you an indication of which equipment items are the most likely bottlenecks in your process. This concludes Part 1 of the SuperPro Designer overview. For more information on SuperPro, please watch Part 2, which will describe some of the reports that SuperPro produces. It will also cover various examples that come with SuperPro, which can be used to gain a better understanding of SuperPro's capabilities in various industries. At the end of that video, there is also a brief summary and conclusion.